Hey, well, these are loading screens, and while they look incredibly simple, they're some of the most intricate and weird pieces of our tech. Because how you wait is more important than the wait itself. Take a look here. This button sends a form, and while we're waiting for the confirmation that this actually went through, we show a spinning wheel for loading. Simple. Now with a fast connection, it will look like this, almost like it's an error. If this was the form for something important, do you trust that it actually sent it successfully? Check out this one. I set a 1 second minimum time where the spinning wheel stays on the screen, making the wait effectively longer, but the result is much more reassuring. See, there's an insane amount of design, engineering, and psychology hidden behind loading screens, and it all works so well that 99% of people never notice. But to understand this, let's go back to our button. See, there's 3 layers that make this all work, and this is the start of layer 1. Because how come here we have to wait for the app to confirm that it's been sent and processed and show all these loading states, but if I type something into Notion or designing something into Figma or type in Google Docs, everything is instantaneous. There's never a loading screen in sight and everything is saved correctly. Well, as it turns out, in many cases you can get rid of loading altogether. But that comes with a problem. This is the product that I built. It's called Flask, and I had the exact same problem. Because early users were complaining that they had to wait until their past comment was successfully saved or the recording was saved until they can record the next one. And so I used the same technique that all these other tools use, assuming everything is a success. Anytime the user makes a change, I just display the change immediately. And then I built a queue system. And every comment that gets added, or really any change that the user makes, goes into this queue. My app is then going through this queue and saving all these changes one by one in the background. There's actually a second queue for saving audio and video of the comments, and only if saving fails, the user is notified that something went wrong, and the change stays in the queue so they can try again later. All of this complexity just to get rid of a few loading screens and waiting. But there's a problem. Let's go back to our example of submitting an important form or document. With this system, it would be instantaneous. It's technically better, but you're weirdly trusting the version on the right much more. Even though your info got saved in both cases, and even though that one is slower, you just trust it more. And that's because loading screens are not just there as placeholders for waiting, they play deeply with our psychology. If we are doing design work with dozens of little changes per minute, constant loading frustrates us. But for things that we deem important, like a payment confirmation, sending over our fees, while the actual bytes moving through the internet might be super small or insignificant, these feel much more important. And we need a loading state to reassure that the important goods have been delivered. Have you ever stalked the Instagram profile of your 10 out of 10 crush and got super worried that you might be liking a photo from like 5 years ago and look like a creep? Well, the reason why you are on edge while you scroll through that profile is that liking something has been designed as an immediate and fast action with no loading or no confirmation, and it is. But for this profile specifically, sending a like carries much more weight. And by the way, we're gonna see so much of this psychology in layer 2. But layer 1 is this. It's the insane designs that go into handling how you wait. And it's not just design, but engineering as well. So has this ever happened to you? You're trying to copy some files and the progress bar gets stuck at 99% for ages. First it says 5 minutes remaining, then 35, then back to 12. Why is it always wrong? Well, let's just try and build one. So first, let's count the files that we need to move and update when each one is done. But wait, there's one giant file and a bunch of small ones, and this breaks everything completely. Okay, new plan. Let's count the total size in megabytes instead. Well, this also doesn't work because copying many small files takes more time than one giant file of the same size due to how file systems works. So, okay, let's calculate an estimate by dividing megabytes transferred so far by the time elapsed, but this is also wrong because you might have started transferring fast, but then you started another transfer in the meantime and it's slower, and then your calculation is completely off. And designing a simple progress bar has turned into a nightmare. The closest we came to, and what most properly designed progress bar do, is take a window of time, say the last 10 seconds, average the speed of the transfer for that time, and that's what we use for the prediction. But as it turns out, we can do better. We can tweak your brain into making the wait seem faster. So which one of these progress bars would you perceive as moving faster? Most of you would say the bottom one. See, this guy, Chris Harrison at Carnegie Mellon, discovers something wild. If you add a ribbon to the progress bar, like little stripes, and make them move backwards opposite to the direction of progress, the bar feels 11% faster. And that's why this shimmer animation on progress bars, it's everywhere. It's not just decoration. Or take these two loading indicators. They are the same duration, but one is making you feel like things are going faster. By being animated, this one gives you the idea that, hey, stuff is happening. But it goes deeper than that. This is the loading state for when I'm loading an asset on Flask. I first added this rotating spinner indicator, but it felt a little slow. So I just tried something simple. I doubled the rotation speed, and while the loading time is exactly the same, it feels much faster. It feels like more stuff is actually going on. The lengths to which designers and engineers go to make products feel faster is still incredible to me. It's happening to you every single day, and you probably never realize it. Like in Gmail, for example.
When I worked on the Gmail team, you know what they did? When you typed in your username or your email address, even before you've entered in your password, probability once you enter in your username that you're going to actually sign in is extremely high. So why not just start loading your account in the background? Get it ready, prepare it. I always thought that was so fascinating and unintuitive.
This is Kevin's system, and after Gmail, he founded another little company called Instagram. And guess what?
You'd take your phone, you'd take the photo, and then you'd go to the edit screen where you would caption it. Why don't we just do that, but like, we'll just upload the photo and like assume you're gonna upload the photo. And if you don't, forget about it. We'll delete it, right? So what ended up happening was people would caption their photo, they'd press done or upload, and you'd see this little progress bar just go thoop.
But this was just layer 1, and things are about to get much more interesting. Take a look at these two chatbots. Which one do you think gives the best, most accurate answer? They are the same AI model, they're the same answer, but most of you would have said the second one. Well, this stuff is layer 3, and that's what happens when we mix loading screens, AI, and the perception of intelligence. But before we get to that, so many of you that follow this channel also build tech for a living. Founders, CTOs, designers, engineers, and if you do everything right and your product starts getting traction, you're gonna start to see some big teams and enterprise companies approach you. They like the product until you sit down with them and they ask you, hey, are you SOC 2 compliant? Are you ISO 27001 compliant? I know, because it's exactly what happened with me with Flask. And this is where the friends of the channel at Vanta come in. As a founder and builder, you should focus on what you do best, which is building the best product you can. And let Vanta automate your security processes and maintaining compliance. It helps you achieve and maintain compliance with over 35 security and privacy frameworks, including SOC 2, ISO 27001, and HIPAA. And it does the best thing for any product team, which is freeing up your time and energy for the things that actually matter in your product. To all the fellow founders and builders that follow my channel, Vanta is offering $1,000 off Vanta. Just go to vanta.com/Enrico, that's VANTA.com/Enrico for $1,000 off. Oh, and feel free to share the link in the description as well to other founders or CTOs. But now back to the video, because this is where we start to dive into the weird side of waiting that has a lot to do with this, your psychology. This is Google Flights. You hit search, and what actually happens behind the scenes is that the poor people that built this needed to use digital infrastructure literally from the 80s to get info about your flights and bring them to you in this nice UI. But that takes time. So they added these little messages. Skyscanner, the same thing. In a study by Harvard Business School, users were willing to wait for longer and actually rated the product more favorably when these were here, because they trusted that the system was doing a thorough search. But here's the thing. While the Skyscanner, for example, these pieces of text are actually mentioning airlines and providers for that route, you can also just fake them and have the same effect. Google Flights shows you the exact same pieces of text on every search, and they take the exact amount of time every single time because they're just pre-programmed. Hell, you can even write completely absurd ones. If you're an OG, you remember The Sims and their amazing loading screen text indicators like reticulating splines or adjusting emotional weights. Or you can just make other things appear to keep you occupied. This is one of the core principles behind waiting, and our tech is a masterclass in designing around this. Occupied time feels shorter than unoccupied time. This came out of a paper in 1985 called The Psychology of Waiting Lines. And it seems like something obvious, but think about it. Uber shows you the car coming to you in real time. They don't need to do that. They can just say, hey, in 3 minutes, a car is gonna be there. But seeing the car zip through the city keeps you occupied and the wait feels shorter. Domino's Pizza shows you all the steps of your pizza preparation, not because it's necessary, but because it's actually easier to reduce the perceived wait time by doing that versus actually getting the pizza faster to you. And remember our progress bar from before? The one that's impossible to estimate accurately? Well, we can build this into that too. These two loading bars take the same amount of total time. But which one feels faster? Well, this one. This is something called the gold gradient effect. We speed up when the finish line is in sight. When I had a project at school or university, the last hours are where I got everything done because the deadline was just around the corner. So we can use this to design loading screen that goes lower at the start artificially and accelerate them near the end, taking into account all the calculation that we ran before. We can even make it take longer artificially and make the final 10% look faster, and it will still be perceived as faster. But if you really want to see how far this goes, video games might be the best example, because usually games take a long time to load and they can get a bit more creative than your tax software. For example, in 1994, Namco released the Ridge Racer on PlayStation. While the game loaded, you could play a full round of Galaxian, completely different game. Complete it and you unlock 8 extra cars. But Namco patented it. For 20 years, nobody else could put a minigame in their loading screen. But let's pause for a second. I know what you're thinking. Why are we even making all this fuss about loading screens? Today, I open my laptop, it wakes up immediately. Processors are incredibly fast, internet connections are incredibly fast. We barely even see this anymore. Well, that's true. But since November 28, 2022, we actually spent a lot, and I mean a lot more time waiting. Not waiting for files to load or something to download, but waiting for these. ChatGPT, LLMs, AI chatbots, they are everywhere now. And while they are revolutionary and cool, what is the one thing they all have in common? Well, compared to the rest of our tech, they are incredibly slow. So now waiting has become infinitely more important. Also because it's directly correlated to how much we perceive these models as intelligent. This is layer 3, and it's where things are about to turn ugly. Take a look at these two chatbots. Which one do you think gives a better, more accurate answer? Most people pick the one on the right. The one that takes longer, and it's writing the answer word by word just feels smarter, more thoughtful, like it's actually thinking, and it's not an accident. Remember when I told you on Flask, I purposely made my users wait longer? Well, this is it. The core idea of Flask is that instead of typing long comments to convey your feedback and creative ideas, you hit record and you just ramble. You show your screen, you draw on an asset. Once you're done, Flask analyzes all of that and writes out a comment for you. And so when I first built it, I designed this loading state. It's telling you what it's doing, the shimmer effect is cool, it forces that something is happening, the pixel grid in the background as well, super cool. And what we are doing here is we are waiting for the AI model, Gemini in this case, to finish processing and give me the full answer once it's done. So in the first version I built, when I got the answer back, I just displayed it. I mean, what else should I do? But when showing this to users and also trying it out myself, it felt weird. So I made one little tweak. Even though we have the full message already, I made it so that each word appears sequentially with a delay. Same exact answer, same AI model, actually takes more time, but with this change, now it felt magical. As if someone is writing the comment for me and users trusted it more. This is actually how ChatGPT and Claude and many of these models works under the hood too. These models essentially guess what is the next word and they string the response to your device. But think about this for a second. Right now we can run the original ChatGPT model 3.5, the one that came out in November 2022 at almost instantaneous speed, but nobody would use it. Because when it comes to AI, we don't want fast. We want the fastest response that makes us feel like we trust it. There's a name for this. It's called effort heuristic. If something takes longer, it must be better. And it doesn't just work for people, it works also on how we perceive machines too. And Google, for example, is finding this out the hard way. Google has always been proud of their speed. They literally show you how many milliseconds your search took. So when they launched AI overviews, they needed to make them fast. Usually Google searches are very quick. And because of this, they need to use less intelligent models, so whenever it makes a mistake, your trust is broken. The same speed that made Google search so powerful is now making their AI feel unreliable. And here's what's counterintuitive. As AI gets better, we're not gonna stop waiting. Actually, the opposite. We will always want a model that makes us wait, because that's the most intelligent. And of course, we don't want to wait 3 hours, but we're gonna just trust it more. But let me ask you something. Have you ever wondered why we have super smart AI chats that start to replace entire jobs? We're spending billions on AR goggles and VR that no one will ever use, but still they cannot fix AirDrop not working. Printers are still horrible to work with. It's almost as if our tech is running at 2 different speeds. Well, this is not by chance. It's because of one of the weirdest laws that decides how our tech actually gets built. And you can learn all about it in this video right here. I'm Enrico, and I'll see you in the next one.